In this video, we're going to talk about how to solve a linear inequality in a single variable. Now, when I say a single variable or one variable, I don't mean literally one variable, one letter. I mean one type of variable, like only x's or only y's, but not both. All right, so the way we're going to explain this is actually to back up a little bit and talk about equations for a second, and this will better help us better understand how to solve inequalities, believe it or not. So we're really good at solving linear equations. An equation has an equal sign, and when it does, we'll put the variables on one side and we'll move the constants to the other. So we'll subtract 1 and get 2x equals 6. We'll divide both sides by 2 and we'll get x equals 3. So this is our solution to the linear equation. Now the thing I want to stress here or point out is that there's one solution. When you have a linear equation, you don't get many types of solutions, you just get one solution. 3 is the number that if you plug it in the equation, it makes the equation true. 2 times 3 is 6, 6 and 1 makes 7, 7 equals 7, and if you had a number other than 3, it would not equal 7. I think that's something we all understand. All right, now let's think about an inequality. Now, because these guys are new, we don't really have any formal steps yet or anything like that. So let me just take a crack at it. I'm just going to just off the cuff guess a few numbers. If I said x equals 4, would that be considered a solution to the inequality? That's basically like asking, does it make the inequality true? Let's see. 2 times 4 is 8. 8 and 1 make 9. 9 is greater than 7. So 4 is a solution. Awesome. So does that mean that we're done and we can go to the next problem? Unfortunately, that's not the case. If I tried 5, 2 times 5 is 10. 10 and 1 make 11. That's bigger than 7. So that's a solution. And so is 6, and so is 7, and so is all the rest of these numbers that I would try. So that's a little confusing. How can these guys have so many solutions? Well, it's because we're not restricted anymore to simply equaling 7. It could be anything that leads to a number greater than 7, which opens up the floodgates for the amount of solutions that we would have. So here's a very important principle we need to understand. Inequalities, these guys have way more solutions than an equation would have. So now the natural question is, how do you express that many answers? We can't write them down, that would take too long. So do we have any way better to express a large volume of answers? And the answer is yes we do. So when we have an inequality, we're going to express their solutions on a number line. This is why inequalities are often associated with number lines, is because I can draw a picture of where all of these numbers are better than I can write them out by hand. And the second thing I want to mention before we try some examples is that these guys are actually solve the steps in exactly the same way that we would solve a regular equation. So we have all the skills in our tool belt already for how to solve these guys for x. There's just one small exception. If at any point you ever have to multiply or divide by a negative value, whatever that inequality is will need to be reversed to point in the other direction. That's very important, and so we'll make sure to try a few like that. Okay, so let's try a few examples here. So here's our first example. We have 2x plus 1 is greater than or equal to 7. So I'm going to treat this like an equal sign and just make sure we never divide or multiply by a negative. So I'll subtract 1 from both sides. So we'll get 2x is greater than or equal to 6. I'll divide both sides by 2. And I'm not going to flip this inequality around because I'm not multiplying or dividing by a negative. So we get x is greater than or equal to 3. So this would be my solution. That's somewhat clear as far as what x's that represents, but oftentimes it's better to see this with your eyes with an actual picture. So that's what we'll do next. So let's see if we can draw this on a number line. So here's our number line, and we'll have, whoops, there we go. We'll have 3. Here's 0, 1, 2, here's 3. And we want to plot or graph all the x's greater than or equal to 3. So if you're looking at the numbers greater than 3, those are the numbers over here. Okay, so we'll shade this side to the right of 3. And since it's x greater than or equal to 3, then that means 3 is included, and we're going to put a closed dot. If it's an inequality that's or equals to, like this one, you actually get to include that point. All right, now let me actually make another comment about that. If your inequality has one of these two symbols, we call these guys strict inequalities, meaning you can't equal the other side. You can get right up to it, but not equal. And so for these two, you would draw an open dot on your number line. So if this had been x strictly greater than 3, we would have done an open dot as opposed to a closed dot like we did here. All right, but on the other hand, if you have less than or equal to or greater than or equal to, we'll put a closed dot for our number line. So this is a picture type of representation for all the solutions. So if you look back on the previous card, where are 4 and 5 and 6 and 7 and 8? Where are all these solutions? Well, if I look back at my number line, they're graphed. Here's 4, here's 5, here's 6, here's 7, here's 8. All of these would be considered solutions. And on the other side, if you tried somebody, let's say back here, maybe like 0 for example, I'm guessing it would not make the inequality true. Let's try it. 2 times 0 plus 1, that is not greater than or equal to 7. So anyway, that's how we solve linear inequalities. Basically, you solve them the exact same way as you would a linear equation. Just remember to flip the inequality around if you multiply or divide by a negative. And you express these answers typically on a number line just because there's so many solutions. Now, there is another way to express the solutions for an inequality, and that's using something called interval notation that we'll talk about in the next video.